I want to give just a couple minutes to talk about the OBD compliant features of the Power Stroke. Now, we have mode 1, the data stream. We're going to show you in this program how we specifically focus on areas we want to test for specific functions and how to group data together for it. One of the strengths of this program is we're going to rely heavily on data stream to point us in the right direction. There's a number of ways to get direction. If we have a failure, we can get direction from the freeze frame. This is the data stored at the time a trouble code was set. And we've got our trouble codes showed to us in 3. Use the trouble codes to give us a good diagnostic direction. And before you clear the codes, make sure you've got the freeze frame and mode 6 data. Now, mode 5 was oxygen sensor information that's now been brought into mode 6. And mode 6 has some very important things for us. We'll go into this in more detail as we go through the program. But mode 6 lets us look at things like misfire and EGR activity and see if there's any pending failures or near failures in this market. Pending codes are trouble codes that take 2 trips to mature and we've only had 1 failure. It'll be codes that'll set later. And bidirectional codes let us do things like check the evap system in the service bay for 40,000 leak. We're going to talk a lot about bidirectional controls and the things we can do because it'll be important diagnostic tools. Mode 9 is vehicle ID. This is what we'll use if we need to do a TSP. And then when we talk about TSPs, we have some of the most popular TSPs is an index in the back of the book to help you identify some things. Some of you may be working on vehicles where the TSP has not been implemented yet, and they may be of value to you. They give you some good indications, stuff to look for. And mode 10 is an inspection and maintenance mode. It's modes that only clear after the vehicle has recorded 3 good trips. If you disconnect the battery or try to clear codes with a scan tool, they will not clear. We have some things what we need to understand about mode 6 in OBDII. OBDII means we can access trouble codes and we can get a starting point for a problem associated with the code. That ever is a given. We want to go beyond that. We don't want to just say this. We got a code means replace something. It means testing it, and testing it requires more tools. Here's an example. This is a scan data screen we're looking at here. We're looking at mass airflow and manifold vacuum, and we're looking at different situations. We have a variety of things we can look at. We're going to be using the auto ingenuity here because it gives us all the functionality that we can find with the Ford test equipment and the IDS in a format that lets us work on Ford, GM, Chrysler imports all together in one product. We like the IDS. It's great, but we have to use something that gives us access to more stuff when we travel around. Here's some grafting scan data. Grafting we use for action reaction. When we do an action, does something follow along and we get the expected reaction from the vehicle? We're going to show you how to utilize this. What I'm trying to tell you is we're going to do more with this. And as we told you, mode 6 has the misfire data. Here's misfire data that's available to us. Here's our misfire data in mode 6. It breaks us down by cylinder, shows us a number of different things, tells us about it. You notice a lot of yellow things that are not supported. We do only a few things with a diesel, but they're a very valuable, useful piece of information for us we need to understand. We're going to use bidirectional testing. Here we're taking individual injectors and we're turning them off and on, and we're controlling individual injectors. We can also do power balance and other things along the things. So we can do power balance. We can do all sorts of various things. Well, heavy-duty vehicles, those vehicles greater than 14,000 pounds, are certified under engine manufacturer's diagnostics. That's up until 2009. They require the same functionality type things we had with OBDII, more or less. They got to look at fuel delivery, exhaust gas recirculation, particulate matter, the emission-related things, and so forth. It looks for outputs for continuity and functionality. It's very similar to OBDII, as we said. Starting in 2010, it is now updated to require functional monitoring of the NOx for the after-treatment system. So while you have a lot of the same stuff we had before, it's going to be very much like OBDII. We'll have a lot of the same information available to us.